Hi guys, this is my first video lecture on the structural mechanics. In this video we'll be covering all the basics and then we'll go forward accordingly. So let's begin our journey to structural mechanics. So what is structural mechanics? Well, all structures are designed for some specific purpose, whether it is simple or complex, but they must be capable of carrying the loads that they are designed for without collapsing, right? So while designing or analyzing these structures, what are the basic terms that you are going to keep in mind? Well, first one is forces and moments, then second one is types of forces and the deformations because of that force. Then third, you need to check whether the system is in equilibrium or not. Then what are the stresses developed in the system, and then what are the corresponding strains. And these are the basic terms that we are going to discuss today. So, whenever any material is subjected to external load, it deforms. It changes its shape due to the application of force or change in a temperature. Like material expands and contracts whenever there is a variation in temperature. You all must have experienced this thing in your daily life. So, mechanics of material allows us to predict the deformation in the material, using which we can predict the failure of structure. As you can see in an example given, the structure is subjected to various loadings and constraints at some location. So what do you mean by constraints? Constraints are like something you can say hold the structure. Like if you talk about cantilever beam, fixed end is constraint. There will be no displacement on rotation. There are different type of constraints and we will study about them in our second video lecture. Now, what happens when we apply external force to any object? It produces internal forces. Okay, and these internal forces will lead to the deformation of the body. So now stresses are set up in the body and so the corresponding strains. And by using these stress and strain relationship, we will predict the failure of the object. So all these things will come under topic of theory of failure. Since this is the first lecture, I am just giving you the brief of everything. We'll discuss everything in detail. We will now see the type of forces. Well, the first one is external force. So by the name itself, you can say that these are the forces caused by the external agent outside of the system. Now it can include applied force, normal force, tension force, or say friction force, or air resistance force, correct? Now if your load is concentrated on one point or acting on one point only, it is said to be concentrated load. But what do you mean by acting on one point? It simply means that the contact area is very small, and so we say that it is acting on a point. After this comes body forces. This from very beginning of your engineering, that the forces due to gravity, electric fields and magnetic fields are body forces. So we can conclude that the body force is a force that acts throughout the volume of the body. Next type of forces is surface load. Surface load is that is applied on surface. Example, pressure load. Pressure load is a surface load. Then line load, water line loads. These are the loads that act along a line, like this. For example, the weight of the partition resting on the floor. It's a typical example. Now next, internal forces. Internal forces are forces exchanged by the objects in the system. These are the forces which hold an object together when external forces, or let's say loads, are applied. Let's take an example of this bar. When you are applying a force F on this bar, internal forces, which you can see they are distributed, come into action. These forces will resist the movement, or let's say elongation of the bar. Okay, so these are the internal. Then deformation. As already discussed, that whenever load is applied, it leads to the deformation of an object. When you apply load in an axial direction, then it will deform into axial direction. It can be a tension or it can be a compression. So accordingly, it will elongate or it will short. It will get short. That depends on what type of force you are applying. Okay. When you apply force parallel to the cross section, like shown in the figure, it will deform, and that deformation is measured as the total angular change in radians at the corner, right? Similarly, when you apply twisting force, it will also result into angular deformation. But what is the difference between both the deformations? The difference is, like, shear force will lead to in-plane deformation and twisting will lead to the out-of-plane deformation. Bending moment, it bends the beam, it will elongate the one surface. After applying forces, all we need to check is whether the system is in equilibrium or not. So when you say that the body is in equilibrium, well, the body is said to be in equilibrium if the resultant of all forces and movements acting on it is 0. So first one is resultant of all forces must be 0, and the resultant of all movements about any point must be 0. So you can take any point and just find the resultant of all the movements about that point. It should come as 0. We have an example here. Here force P is acting at an angle on the free side of the beam. So to be in equilibrium, force P will act at the fixed position but in the opposite direction. This is the solution. So we'll discuss some solved questions on this topic in our second, or I think third lecture. Then, to investigate the internal resistance of a structure, the most famous method is a method of sections. Consider a single bar that is under tension and take a cut at any cross section to see the internal forces. Now your bar is divided into two parts. Now separate each part. Then by using equilibrium of force, the force on cut section must be equal to F. Similarly, the force will be acting on the left face but also in the opposite direction. Now our next topic is stress. Well, if you will go by the definition of the mathematical entity, stress is nothing but the force divided by area that the force acts upon. But this is not at all. No, this is not all. Stress is a physical quantity that expresses the internal forces that neighboring particles of a continuous material exert on one another. So we have two types of stresses, normal stress and then we have shear stress. Now check this example. The axial force produces a uniform stretching of the bar. Hence the bar is said to be in tension, as you can see in the figure. Now to investigate internal stresses produced in the bar, we will make an imaginary cut section at mm and nn. Since nn cross section is near to the load, it will result in high localized stresses and non-uniform stress distribution over cross section in the vicinity of the load. As we move away from the end, that is towards mm, the stress distribution generally approaches the uniform distribution. So what we do is we generally take the average of stress. As you can see in the figure, this one, Fs is also producing shear stress on that face as force is parallel to the cross section. Okay. Now comes the strain. Strain is a measure of the deformation of the material. Normal force will either elongate a bar or contracts a bar, and that depends on the nature of force, and corresponding strain will be normal strain. So here, if you are applying a force F, so your length is changing from L to L plus delta L. So what is the increment in length? It is delta L. So delta L divided by L will be your normal strain. Similarly, we have shear strain. So when a shear force is applied, the body will deform, and the measure of the change caused by the stress in the right angle between the two fibers within a plane. You can see the figure here. So this is our rectangular box, fiber 1 and fiber 2. So when you are applying a shear force on this, you can see how it is getting distorted. So our total shear strain will be alpha 1 plus alpha 2. This is all for the first lecture. Thank you for your attention, and you can proceed with the second lecture. Thank you.